So we'll talk about replicating, which is replicating a derivative. So a derivative, like an option, is something you can just go and purchase for a fee. What we're going to do is we're going to try to, instead of purchasing the option, we're going to take some of our own money, maybe borrow some money from the bank, and actually purchase the stock so that at the end of the period of time, the amount of money we have will be exactly the same as what the option payout would have been. And if we could do that, then we figure out how much money would we have to put up today to replicate the derivative. And that should be exactly the same price that the option is paying in the market. So our model goes like this. Our model has time, which is, this is 0, 1, 2 discrete intervals of time up to t. And we have states, we'll call omega. We'll have states that the market can go to. So like the market, stock market, if you go up or down, and up at a certain value, down at a certain value. And as time goes on, we can get omega 1, omega 2, and omega n for n different states. Okay, we have P assets in our portfolio. And the stock price at time, the stock price at time t, under a certain market condition, omega, let's say the market does well, the market does bad, the stock price under a certain omega, this S of t is equal to the stock price at time t. And if we wanted to, we could do this. We could, I'll write it this way. I'll say the stock price of asset I at time t. So there's two parameters, time and the market condition. This is the stock price at time t of asset I. Okay. So now we're going to define, and again, this is just some notation. Okay, so this is a vector of a function of all prices at time t under condition W. So this I'll go through an example shortly of what I mean by condition W. We'll go through a really simple example where we'll say like either the stock price is doubled or the stock price has gone in half and there's no gray area. But this ends up being the all prices. So this is a vector of all prices of all these stocks in our portfolio. So if we have 4 different stocks, then obviously at some time in the future they'll have 4 different prices. Okay. Okay, so now let's look at an example that goes like, let's look at a 1-period model, a binomial model. And we've kind of had, well, first I'll go over a concrete example, just to make it a little easier to follow. But let's say we had a stock that's currently $2, and in the future, it could be either $4 or $1. And we've seen examples like this before. So, in this case, we have the stock price is currently $2, and it's a type of stock, it's like it doesn't have the ability to be any price in the future. It's either guaranteed to be worth $4 or $1, one-time unit into the future. Okay. So, that being the case, let me now just put in theoretic, like so let's say we wanted to define, this is the upside, and this is the downside. If we wanted to calculate what is, we'll have a variable called U, this is going to be equal to the stock price if we have an up market. The market does well and this stock goes up. That price divided by the stock price at time 0, which is equal to 4 divided by 2, which is equal to 2. So there's like a multiplier. The stock doubles if the market goes up. And then we'll have an indicator of something called D, which is the stock price if it goes down in a down market divided by the original stock price, which is equal to 2 which is equal to 1 divided by 2, which is a half. Okay. So the theoretical way of describing that would be like this. U is equal to the stock price at time 1. This is a one-period model, so there's only one time unit later. If there's an up market, divided by the original stock price, and D is equal to the stock price at time 1 in a down market, divided by the original stock price. Now, what if, hypothetically, there was an interest between the two periods, the first time equals 0 and time equals 1. What if there was interest? And the interest rate R, we have a rate R, a risk rate R. What's something we could say about U and D and R? Suppose, hypothetically, we had an investment, S0, and it could go to S1 up market or S1 down market. What if U and D were both larger than the interest rate? What if they were both, what if this was the case? What if that were true? Now, just because I'm using the words up and down, if it's a down market, think of it as like a really good and maybe somewhat good. In other words, if the down market produced a better rate than the interest rate, what could you do if you were an investor? In other words, this number U is really like in the example we did last time. You started off with $2 and ended up with $4, so you doubled your money. This U is kind of like 200%. It would be like an interest rate of 100%, right? It's 100 plus the interest rate, so 200% being right? Does that make sense? That this would be in the last example, this was equal to 200%. And this one was equal to 50%. Right, wait. 200%, which means R equals 100%, like 100% interest during that time period. This was 50%, which means our interest rate was what? We had a negative interest rate, we lost money, right? What would our interest rate be? It would be 1 plus this number. 1 plus what gets to this number? It would be minus 50%, would be our interest rate. What if, hypothetically, the 1 plus the interest rate was less than D? In other words, the worst case scenario for the stock did better than if you went out and put the money in the bank and gained interest. So suppose our investment, best case and worst case, both beat the interest rate. Suppose that was the case.
It's like Japan, didn't they have a negative interest rate?
Well, a negative interest rate is kind of strange because you would have to, I mean, you're holding the money in your hand. You wouldn't put it in a bank and get a negative interest rate.
Right.
You'd hang on.
That was
to
the
it.
whole thing. They wanted you to stop saving and start spending in Japan.
Right, right.
Something like that.
But anyway, let's just say hypothetically, the worst case scenario. So this is a stock. Like we said, this doesn't happen in the real world. It either has one price or another price. That's not true in the real world. But what if the worst case is better than putting the money in the bank, and the best case is even better than that? What would then happen?
You invested.
You would do what? You would borrow the money from the bank, and then buy the stock. Whichever case happens, you're going to come out ahead, right? And then you pay back the bank. Even in the worst case, you get a better rate, and then you pay back the bank and pocket the difference. So if a stock like this existed, if there was a stock option that existed like this, I'm sorry, if there was a stock that existed like this, you would borrow money from the bank and buy the stock, and then no matter what, come out doing better than the bank. So this would not happen. There would be an arbitrage if this happened. There'd be a guaranteed way to make money. Borrow the money and then invest in the stock. What if, so this is choice A. What if this happened? What if the best case scenario was worse than the interest rate for a particular stock? What would happen then? Or what could you do then? In this case, so this is what I'm just trying to get you used to thinking is, no matter what the scenario is, whether it is either you lay out your money buying a stock and then later on get your money back, or you can borrow money now to buy a stock and then sell it and pay the money back, every transaction, the opposite transaction can be done. So if there was a case where the interest rate will definitely pay better than this stock, no matter how good or bad the market goes, the interest rate will do better than that, what could you do? You could do the opposite of selling the stock, right? Instead of laying out money to sell the stock and getting the stock, you can actually, what they call short selling the stock, you can actually get the cash for the stock. You could give away the stock, in other words, it would be the same as selling the stock. You could sell the stock to get cash, put the cash in the bank, and then have it grow, and then buy the stock back at the old price. You could sign a forward or future contract, put money in the bank, and then have a guaranteed profit that way. So if either one of these two states existed, then there is a way to have guaranteed profit. And that would mean that this system had an arbitrage in it. So there was an arbitrage in the market, if one of these happened. So as a rule of thumb, take this down. As a rule of thumb, in a, as a rule of thumb, this should be in an arbitrage-free market. We should always have this scenario. Should always be true. So when we were talking about the graphs, like when you were doing the profit graphs for any investment you could do, what does this tell you? This tells us that if we had a graph and we made a collection of investments, if we made a collection of investments and then charted our profit line, if our profit line always did worse than or better than the interest rate, always did better than this, no matter what the result was. So let's say the interest rate goes like, 1 plus the interest rate goes like this. If you put money in the bank, you'll travel along this line. So this is times going out this way. If we had an investment that no matter what the market did, always stayed above this line, no matter what, if this was our profit for our investment, we would be guaranteed to make a profit if we borrow money and buy the investment. And if there happened to be another investment that was always below, no matter what happened, no matter what the market conditions are, we could never do better than the interest rate, then we could sell the investment and put the money in the bank. And then at the end settle up and we'd be guaranteed to make a profit. Okay. So let me go over one example. This is an example of a European call. So do you know, but just from the reading, do you know what the difference between an American call, a European call, and an Asian call is? Or, well, okay, so anyway, just briefly. A European call, that's an option, that's a stock option where two people agree, one will pay a fee to one person, and then at some point in the future, if the stock, if it makes sense, the buyer of the option has the option to exercise the option that they agreed to. In the European call, the only time you can choose to do it is on expiration date. So if you agree 3 months from now to do it, the only time you can do it is 3 months from now. An American call can be done anytime between today and 3 months from now. Like 2 months later, you could say, I want the stock now. You don't have to wait until the last day. So that's an American style option. The European style, the only time is in the future, is the day it expires. Okay, so that's why you see in the textbook it always, a lot of the examples are simpler to follow as the European call version. So if we had a European call option and we have a stock price, okay, so K, which is the stock price, the stock price, I'm sorry, the call. Oh, wait, sorry. Let me first example I wanna go over is like this. S0 equals $4. And if you go up, so U is gonna be equal to a factor of 2. So it can go up to $8, and D is going to be equal to a factor of a half, just like we did before, so it could go down to $2. And we're going to look at a European call with a strike price of $5. Okay, and we have an interest rate of 25%, which is the same as saying 25%. Okay. So what does this mean in this example? If the stock price so the time period, there's just one time period when we get to this point in time, and from here to here, let's say it was a 1-year period, there's 25% interest. The current interest rate in this country is 25%. So, 1 year from now, what will the value of this option be? 1 year from today, everything above $5 is a profit to the person who's buying the call. It could be $8 and it could be $2. So what would the profit be 1 year from today?
$3?
If it goes to $8, if the market goes up, the value of this option would be $3. If the market goes down, the value of this option would be, because it's an option, you don't have to exercise it, it would be what? It would end up being 0. Because, you would never buy the stock for $5 if it's currently selling for 2. You have the option to buy it at 5. So if it goes above 5, you would buy it, and everything above 5 is profit to you. So this thing will either be worth $3 or 0 in the future, right? We don't know, I think the examples we've done before, we have the probability to go up and the probability to go down, and then we calculated back what the value would be today. But right now, we don't know what those probabilities are. We just know it may be worth $3 and it may be worth 0. Okay. Right, so far that makes sense. Again, there is no stock that actually behaves like this in the world, yet. But we'll try to simulate that in the future. Okay. So now, suppose we're considering buying this option, and we're trying to figure out what is it worth, we as the buyer of the option. What do we think it would be worth? First of all, before we even do any calculations, can you have a max and a min on what this thing is worth? Like what could you argue it could never go above what price?
$8?
Wait. And 0 profit. So there's a possibility you'll have a $3 profit and a possibility you have no profit. And you're being asked to pay some fee today to have those two possible opportunities. What is a price, what could you argue is a price you would never pay more than, before we do any math? What would you argue is a price I'd never pay more than 3, because the most I'll ever get back is 3. As a matter of fact, if you pay 3 now, you're gonna lose some interest on this too. So it actually you could say 3 discounting for the interest is the most you'd ever pay. And you'd only do that if there's a 100% chance you'd hit this. There's not even a 100% chance. So it's definitely a lot less than $3. Could you argue that it would be worth more than a certain number? Is there some number it's definitely worth more than? Even if it's a ridiculous number. Is it? It's got to be worth more than 0, right?
Right.
Because it can't lose. This thing will never cost you anything. Worst case scenario, you get 0 back a year from now. So, if somebody ever said, well, I'll, to pay a negative number, you'll collect $2 to get this option, that doesn't make sense, because you'd be making money and without a doubt not paying anything in the future. So it's somewhere greater than, it's definitely worth more than zero, because it's better than nothing. It's like a lottery ticket, even if you have no chance of hitting the lottery, it's worth more than zero. But, so it's definitely worth more than zero, definitely worth less than $3 discounted back to today's money. And then really what it comes down to is what are the probabilities of these is gonna, we'll get a tighter squeeze on what the value is. So right off the top, we can see that that's the value, that's a range for the values. Okay, now, suppose we did this. Suppose instead of buying the option, suppose we decided to do this. We decided to start with $1.20. Starting with $1.20, we want to buy a half a share. Now this sounds weird, you might think, can we buy fractions of shares? If we were a large financial company that we could buy big blocks of shares, we can actually buy fractions of them, because we can then buy pools of shares and percentages of pools we could split with other people. So we want to realize that we can start with any amount of money, we have the ability to buy fractions of shares. We would be doing this problem but on a very large scale. And we can buy positive shares and negative shares, we can borrow money or use our own money. Suppose we wanted to do this. Okay, in order to do this, we need 80 more cents. Can I get this right? We want to buy a half a share. The shares are currently selling for $4. We want to buy a half a share, which is going to cost $2. So what I'm doing is I'm kind of saying the answer and then saying, with this answer, let's see what happens, and then we'll figure out how to solve for this answer. But let's say hypothetically we started with $1.20. We need 80 more cents to purchase a half a share. So we're starting with $1.20 and our goal is to buy a half a share. We'll see why we're starting with that and why this is our goal in a second. We need 80 more cents. So we need 80 more cents, and so we borrow 80 more cents. Borrow 80 cents from the bank at 25% interest. Okay, so what's our situation right now? So this is now, we have a half a share and owe 80 cents plus interest to the bank. That's our position right now. Where would we be 1 year later, or whenever this option expires? Where are we going to be? So, let's do this. Okay, 1 year later, or whenever, sorry, when the option expires. Yeah, I'll make it a 1 year problem. 1 year later, where would we be? How much money would we have 1 year from now if what we did was we bought a half a share and borrowed 80 cents? Where would we be a year from now? Well, the market could go up or the market, there's actually two places we could be. The market may go up or the market may go down, right? So if the market went up, where would we be? the value of our money, which we'll denote as X, in an up market, will be 1/2 of a share of the stock, assuming we went up, plus, well, yeah, let me calculate this, let me calculate out this example, and then I'll write a standard formula for us. So if the market went up, we would have what? 1/2 share, and what would we owe to the bank? We would owe 80 cents plus 25% interest. So we would actually have, we'd have 1/2 share minus 80 cents times 1 plus 0.25. So that's interest on 80 cents plus 1/2 share. So what does that equal? That equals, what is 1/2 share if the market went up?
$4.
$4, right? So 1/2 times 8 minus, and 1.25 times 80 is $1. And that equals 4 minus 1, $3, right? So in this particular case, I know it's an odd thing we started with. We started with $1.20, we borrowed 80 cents and bought 1/2 share, and it seems kind of weird, where did we come up with that? But we just want to see what would happen instead of buying the option, if we actually borrowed some money and used some of our own money and bought the share. What would, and let's compare that to what would happen if we bought the option. In a down market, what would happen? In a down market, we still have 1/2 share, no matter what. If we bought 1/2 share at the beginning of the time period, one time period later, we haven't changed anything. So we would end up still with 1/2 share minus, either way, we owe the bank 80 cents plus interest. Which is equal to what? What is 1/2 share? That is 1/2 of, in a down market, the share would be worth $2. Right, it started at 4 and it cut in half, so it's worth $2 minus, once again, $1. And this equals 1 minus 1, which is 0. So again, just as a reminder, we invested $1.20 of our own money and borrowed we borrowed 80 cents to give us $2 to buy 1/2 share. It's just some weird thing we came up with to do. We started with $1.20 of our own money, borrowed 80 at the current interest rate, which is 25%, gave us $2, we bought 1/2 share. Where are we 1 year later? No matter what, we own 1/2 share and we owe the bank $1, no matter what. How much is that 1/2 share? Well, it depends. Did the market do well? Did the market do poorly? If the market did well, we have 1/2 share that's worth $8, which is a total value of $4. $4 minus the $1 we now owe the bank would give us $3 in money 1 year from today. If the market goes bad, we have 1/2 share of a bad investment minus $1. So 1/2 share of something worth $2 would be $1 minus $1. A year from today, we'll have nothing. So does it make sense what this, forget about now how we came up with this, but does it make sense what this investment is trying to do? We had one choice, was to buy the option with a strike price of 5. The strike price of 5 meant we get everything above 5, so we could either gain $3, or if the stock went down to 2, we would have nothing. So if we bought the call option, 1 year later, we're either gonna have $3 or $0 in our hands. Right? That was the original call option. Now we're not doing the call option at all. What we're actually doing is we're just using our own money, borrowing money, and actually buying the stock itself. Now, we're gonna own some of the stock, but we may also owe money to the bank. So whatever we own in stock, we have to subtract off what we owe to the bank and figure out what our net is. If we did this, instead of buying the call option, if we did this instead, start with $1.20, borrow 80, that gets us to $2, buy a share of stock, wait a year, what are we worth? We're worth exactly the same as if we bought the call option, exactly the same. So what does that tell us? Now again, this is a fictitious stock because the stock either goes to $8 or $2, and that's not the real world. But if a stock like that did exist, what would this tell us? What's the risk-free, the risk-neutral arbitrage-free price for this option? If we could replicate the option by borrowing money and using our own money and buying the stock itself and then seeing what our net is, what if the actual option was selling in the options market for any price other than $1.20? So C0 is the cost of the option at time 0. If C0 was not equal to, let's do choice A. C0 is $1.19. What could we do? So what this question is asking is, if in the options market, if you go out to the option, the Chicago Board of Options, look at the prices that they're currently selling at. If this particular option you could buy it for $1.19, and at the same time, we could do the thing we just did. We could take $1.20 and do the thing we just did. We could replicate the option. What could an investor who wants to guarantee to make money do? Any ideas?
Could you buy the 119 and sell them for the 120?
Yeah, okay. That's actually, yeah, right off the top, when you see these arbitrage-related questions, and basically what we have coexisting at the same time in the market is you can buy the same thing at two different if you can buy the same thing at two different prices, what would you do? Let's say there's 2 stores on your block selling a can of Coke, and one store's selling it for 80 cents and another store's selling it for 75 cents. Same exact product. What could you do? You could, and you don't even feel like drinking a Coke at the moment. You could buy a Coke for 75 cents from one store, run across the street and find someone who's about to walk into the other store and say, I'll sell it to you for 80, right? So it's always buy it at the cheaper one and sell it at the higher one. So what can we do if we have the option to buy the call itself at $1.19, and we can play around with $1.20 and replicate the call? What would we want to do? We would want to buy it at $1.19 and sell it at $1.20. So how do we do that? We would, actually this is probably the harder way. Let me do this. Let me do this question first. The slightly easier question, and then once you know the easier question, you just say reverse the previous question. Suppose it was currently selling for $1.21. What could you do? So what that means, this is, even though these two questions, I'm gonna do part B is gonna be $1.19. What would you do? Even though these questions are exactly the same in difficulty, it seems more logical, the first one seems more logical. If the option is selling in the options market for $1.21, that means you could sign up on the buy side or the sell side. Either one's fine with you, and as far as the thing that we just did on the previous screen, you can buy or sell that side too. What could you do in this case? What you could do is you could sell the option for $1.21, collect the $1.21, right? You could be on the sell side. That means you collect the $1.21 right now, but maybe you're gonna lose money in the future. Then you take $1.20 of your $1.21 and do the thing we just did. Take the $1.20, borrow 80 cents, buy a half a share, blah, 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 right? And what will you guaranteed profit be? No matter what happens in the future, you're definitely gonna gain 1 cent. Now, this is, of course, assuming there's no transaction fees and stuff like that, and you wouldn't do it for 1 penny, you would do this, you'd do this 1 penny times 10 million and make it worth your while. But what you could do, in this case, would be, if the options market was, you have the choice of either being on the buy side or the sell side for $1.21, you could go like this. You could say, sell the call, and then do what we did. Yeah, what we did. Use $1.20 and pocket 1 cent and follow previous, follow the replicating. The replicating strategy we did before. If the price of the call was going for $1.19 or any number less than $1.19, what could we do? Exact opposite. So we could buy the call for $1.19. That means we pay out $1.19 right now, and then do the exact opposite of the replicating strategy. And what would the exact opposite of the replicating strategy be? That would be to borrow $1. So what the original strategy was to take $1.20 of our own and borrow 80. So what would the opposite of that be? The opposite would be to take 80. No, we don't want to buy the half a share. We want to sell the half a share short, which means we would receive $1.20. Instead of, like the last time, we would take $1.20 of our own and borrow 80. So now we would sell a half a share short, which would give us immediately $2, but we would take $2, of the $2 we would take 80 cents and put that in the bank, so we would get $1.20 in our hand, and then at the end of that time period we would have exactly the same amount that this investment would produce. So it would be like getting $1.20 in our hand today and being in the same position that the buying this call would be in. I'm sorry, the opposite position of buying the call. So it would have the same effect of paying $1.19 today and receiving $1.20 today, and no matter what happens in the future, we remain unchanged.
And the first one, you don't, when you sell the call, you don't pocket any money?
No, so what we're doing, so what we're saying is, if there was an example, if a market had, if we could replicate the option, that means we don't buy the option. These options are available in the market. We don't buy the option. What we do is we replicate it using the strategy we did before. The strategy was take $1.20 of our own money, borrow 80 cents, buy a half a share, wait a year, and then cash out.
Right.
That's exactly the same as getting $3 or $0. It would behave exactly the same as if you bought the option. If we noticed in the market that the option is going for $1.21, or any number higher than $1.21, what we can do is we can sell the call, meaning collect $1.21, take put a penny in our pocket, pocket, oh, what did I do? Pocket a penny, and take the $1.20 and replicate the call.
Just like you had done the previous.
Exactly like we've done before. No matter what happens in the future, it'll be a push, and we gained a penny. If the stock, if the option was going for anything less than $1.20, we could do the exact reverse, which is buy the call, which means we pay $1.19 right now, and then we do the exact opposite of the replicating strategy we did before, which would get us $1.20 now. So what we'd end up doing is we'd sell the stock short, which means we gain $2. We take 80 cents and invest that in the bank. So we're basically doing the reverse of all the steps. And then 1 year later, we're going to have exactly the opposite of this call. So we paid $1.19 today, received $1.20 today. We pocket a penny, and no matter what happens in the future, we made a penny. And then, of course, do that times a million. Right? Because the penny's not worth all the aggravation. Okay, so what this is saying is that if we could replicate the option, we can figure out the exact price the call should be going for. If the call didn't go for exactly that price, there's something wrong with the market, and people will come in and take advantage of it. So if they were currently selling, if there was a moment in time where they were selling for $1.19, these people who want to make the penny times a million will jump in and buy that, and then their buy orders would drive the price back up to $1.20. So in other words, if it ever flickered to $1.21 or $1.19, it would almost immediately flicker back to $1.20. So the price of the option, in this case, would be $1.20. And there are companies that would have software looking for it to go to 21 or 19, and then buy a block, which will knock it back to 120. So the market will keep driving the price of the call option back to the same price it would cost you to replicate the option. Then there's also minus all the fees, and because there's a lot of transactions involved, and it's also not guaranteed that you're going to be able to do the sell and take the $1.20 and get a loan from the bank and buy the stock all in a same fraction of a second. But if you could do all of that, you could then figure out what the exact price of the stock option should be.